Welcome back. This is the last lesson recording for IM2, September 24th, 2020. So this is where you're going to do some practice, and this is where the students send me a private chat as to what you thought were true. And you ask, the question is, are the triangles congruent? If yes, what condition? Okay, so first you need to determine, are the triangles congruent? And if it is yes, then you need to tell me, is it by SSS, ASS, or SAS, or whatever, okay? And you need to tell me, write the congruence statement as well. That means triangle ABC is congruent to triangle YZX or whatever, okay? You need to figure out the corresponding vertices to do that. Okay, please pause the video and see if you can figure it out. The answer is in 3, 2, 1. Okay, yes, it is congruent because we have three different sides: 9 centimeters, 3 centimeters, 3 centimeters, and 10 centimeters, 10 centimeters. So the three corresponding sides match up. That means triangle ABC is congruent to triangle XZY by SSS. And how did I figure out that which is the corresponding? I know that A is opposite to 3 centimeters. So which is the side, the vertex opposite to 3 centimeters of the side length? That's X. So I know that A matches with X, and I know that B is opposite 10 centimeters. So B matches with Z, and then C matches with Y. So that's why it is triangle ABC is congruent to triangle XZY. Next problem. You're given these triangles. Are they congruent or are they not? If they are congruent, tell me why. What is the condition? Write the congruence statement. Answer is given in 3, 2, 1. No, this is not a congruence. They are not congruent triangles. Why? Because you're told that the angles are corresponding and congruent. However, three angles AAA is not a congruence statement or congruence rule. What about this? Please pause the video and tell me if it is congruent and by what rule. Okay, let's see what we have. We have angle 20 degrees matching up with 20 degrees, and then the included side between the two angles that are given is the 12 millimeters, 12 meters, and then 65, 65. So we're given angle, side, angle congruence. So we know that A matches up with is the vertex that has 20 degrees. So 20 degrees vertex, so A matches up with P, C matches up with R, so therefore B must match up with Q. So the congruence statement is, yes, they are congruent. Triangle ABC is congruent to triangle PQR by ASA, angle, side, angle. What about this? Are the triangles congruent? If yes, what condition? Please pause the video. What do we have? We have side that is 5 matches up, and the included angle between the two sides that match up, 9 matches up, and the angle in between matches up. That means going from one direction. We have to always go from one direction and not skip anything unless it is empty. We have a side that is congruent, followed by an angle that is congruent, and then followed by a side that is congruent. So it's side, angle, side congruence, and the angle B obviously corresponds to Q, and angle A corresponds to P because that is next adjacent to the side with 5, or you can think of it as being opposite to 9. Okay, so it's triangle ABC is congruent to triangle PQR by side, angle, side, SAS congruence. What about this? Okay, tell me. Alright, so this is a tricky one. Okay, so let's see. 16 matches up with 16, 12 matches up with 12, and this angle notch tells me they are congruent. So are these triangles congruent? Well, look at this. You're looking at this, you have side, angle, side. But looking at this triangle, you have side, side. Well, side, we don't have an angle, so it's side, side, and angle. So we have side, angle, side, and side, side, angle. So they do not match up, okay? Even though you are given two equal sides, we don't have enough information. So we really can't tell, okay? What about this? Okay, please pause the video. Tell me what you think. Alright, so in this case, are these congruent? Well, the angles are the same, and the angles are the same, and they have congruent side length, but are the corresponding sides equal? This tells me two notches and two notches and two notches. This notation tells me they're equal to each other, but this notation does not tell me this side length is equal to this side length of that triangle. Okay, so the side lengths are not the same, and without the side length, at least having one side length being congruent, we can't prove congruence. So we have to say no, corresponding sides are not congruent. Okay, what about this? Okay, what do we know about this? What we are told that xz is 6, mx is 6. What does the arrow mean? What does this arrow mean? Okay, think about that. And what other information do we know? Okay, what other information do we know? Okay, so what you should know is that if this means they're parallel lines, so NM is 9NM is parallel to ZY. Okay, so if these two lines are parallel, what do we know about alternate interior angles? So pretend that the lines go on forever in both directions. Okay, then where is my transversal? It's the line that cuts the parallel lines, right? So looking at this angle and this angle are congruent. How do we know that? Because they are alternate interior angles. Okay, so we know that those two angles are congruent. What else do we know? Okay, we also do know that this angle and this angle those two angles are congruent. How do we know that? These are vertical angles. Okay, and likewise we can also say that, let me find a different color, let's see, let's do aqua. Okay, we can also say that this angle and this angle are congruent. Why? Because they are the transversal again of a parallel line, so they're alternate interior angles which are congruent. So we actually have a whole lot more information than what we were originally thought. We have the side as well as the two angles, or you can think of it as the two angles here. So you can think of it as angle, angle, side, or angle, side, angle. Either would be fine. Okay, so this for this, yes, the triangles are congruent by angle, angle, side, or angle, side, angle, depending on which angle that you use, whether you use the vertical angles right here or the other angles. Okay, all right, so then what about this? Okay, it's getting a little bit more tricky. You're given these two notches, and what does this square mean? It means it's right angle, it's 90 degrees. If this is 90 degrees and you know that it forms a straight line, what must be true about this angle? This must also be 90 degrees, right? So it's got to be 90 degrees and 90 degrees. That means those two angles are congruent. So we have side from these two notches tells me that they are congruent. Do we know anything else? Well, we see this line here. We see the side being shared. This is the common side. This is common side, or shared side. Okay, in which case triangle ACD is congruent to triangle ABD, because this is side, another side, and then you have an angle. Okay, so in this case we have angle side side. Now, is angle side side a congruence statement? No, it's not. Okay, angle side side, remember, that's the bad word, is the one that is not a congruence rule. However, what do we know? We have a right angle, don't we? And we have a leg of a right angle, and this is the hypotenuse. So we actually have hypotenuse and leg that are congruent. So in this case, this is congruent by hypotenuse and leg. And the triangles are triangle ACD is congruent to triangle ABD by hypotenuse leg rule. Okay. Alright, then what about this? Okay, this is again tricky. Do the triangles look congruent? Look at this. This triangle, just by visually, they don't look congruent at all to me. So I can say, oh no, it's not congruent. Well, you can't really trust your eyes. Okay, if the notches say that they're congruent, then you have to believe that that is the right thing. Okay, so here, what are we taught? That we know that this angle and this angle is congruent. Do we know anything else? Well, we're told that these two arrows tells me these two lines are parallel. So there's line here and line here. They are parallel lines. That's what these two arrows tell us. Okay, so that means that what do we know about the transversal? Cutting the angle. Okay, if that is a transversal, that means that this angle and this angle, they are alternate interior angles and they're congruent. So that's also congruent. You can also use these notches on the angles to indicate the two congruent angles. Okay, now do we have anything else? Do we have any other information? Well, we have between this triangle, the triangle at the top and the triangle at the bottom, we actually have a shared side or common side. So we have angle and we have another angle and then a side. So if you read from here, side, angle, angle, or angle, angle, side. So we have triangle congruence by angle, angle, side. And so triangle EFHE is congruent to triangle GHE by angle, angle, side. Okay, are these triangles congruent? Well, we're running out of time, so I'm going to go a little bit quicker. Okay, so in this case, yes, we have side, side, angle, right? Is that true? Well, no, we have ASS, or we better known as the donkey, or the ass, and we don't say, we're referring to the ass here. Okay, no, ass is not a congruence rule, right? So that's one thing that you need to know. You can almost even remember that ass is a bad word in math, so you do not say that. Okay, all right, so then in private chat you are going to finish the card 7, I'm sorry, not in private chat. You're going to go back to the decimals and finish the cards 7 to 15 as part of practice, and then you are going to finish by writing the triangle congruence and then doing the reflection.